My dear students, another day of my being sick, and frankly speaking, I've got nothing to do, and I'm hanging around. And again, I've just caught another chemistry-related problem from the same country. Well, sorry, again, this coughing. Okay, it's pre-university chemistry preparation course. Well, and you know what? It's a very interesting assignment, really. It's very interesting not only in chemistry terms, but also in mathematical terms, because it requires deep understanding of the mathematical side of the matter too. Well, and I just want to draw attention to the assignment itself. I've just prepared it for you. Here it is. Yeah. So computer mass fraction of the salt resulted in after adding enough quantity of potassium sulfate into 13.24% solution of lead nitrate. Well, it is a very, very interesting assignment. But before we get down to sorry, before we get down to the main part of the solution, so first of all, let's remember that chemistry is definitely a hard science, which implies very thorough use of mathematical tools. Although this task is from a pre-university course, even at this stage, we ought to understand that each step of any chemistry problem solution must be double-checked in mathematical terms. So let the initial mass of the nitrate be equal to 100 grams. So let's write it down. So is it writing? Yeah. The initial mass this uh, of this solution is 100 grams. Okay. That automatically means that we know how much of the salt is salt. We now know that the mass of the lead nitrate is 100 times 1324. That means 13.24 grams, right? Okay. So from the statement of the problem, we see that the amount of potassium sulfate was enough. At this point, we should make a pause or take a pause to ask ourselves, enough for what? The answer is that it is enough to complete segmentation of the lead ions initially presented in the aqueous solution. That also allows us to go on with calculations to compute the mass of the potassium nitrate formed from the following proportion. So let's write down this proportion. We've got this proportion, okay? Where did I get it from? So first of all, let's write down the complete equation. Okay. 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 Yeah, this is the salt whose concentration they ask us to compute. Okay. And now we've got this proportion, this and this, this over this. So the molecular weight of lead nitrate is 331.2 grams per mole, and that is 101.1 grams per mole, right? But we also should take into consideration the presence of the coefficient too. Well, and we know that 13.24 grams of that salt was initially presented in the solution, right? And now we can calculate from this proportion the mass of potassium nitrate formed as a result of this reaction. So X equals 331.2 raised into -1 degree. Okay, then times 1324 times 2 times 101.1, and finally we've got 808 grams. This is the mass of that salt, which is formed after adding that substance, that reagent, into the aqueous solution of that salt. Okay, the final step to identify the mass fraction of that salt is to identify the mass of the final solution. And how can we do that? Well, we should take into consideration the fact that all of the lead nitrates are gone out of the system. Yeah, because I have just said that the amount of that salt was enough to segmentate all the all the lead ions, right? That means that all this is out of the system. That means that the final mass of the solution is the initial mass of the solution, um, and we should subtract the mass the mass of the lead nitrate, because it's gone due to this reaction. It's gone 100%. However, we should also take into consideration the fact that that mass of that salt stays in the system. Okay, I mean, okay. Um, we can write like this: plus the mass of K on 3. Okay, and that means 100 minus 13.24 plus 808, and finally we've got that the mass of the final solution is 94.84 grams. Now we know how to sorry, how to calculate the mass fraction of that salt. It is the mass of the salt formed over the final mass of the solution times 100%, if you want. Okay, that means 8.8 over 19.84 times 100%, and that gives 8.52%. That's the final answer. Thank you very much for your attention, and please remember that whatever you do in chemistry, whenever and whatever you are dealing with related to chemistry problem solution, so make sure that you do everything in accordance with mathematics. Thank you very much. If you've got any problems, feel free to ask me. I will try to explain to you further or in more detail. Thank you. Bye. And don't be as sick as me now.